In 1938, anti-tank gaps were documented. Major Millerlist Jeffress proposed a poultice charge concept. The requirement stressed irregular close attack methods. Staff judged conventional guns insufficient after evacuations. Procurement files prioritized rapid stopgap devices. The design target was hand emplacement. The intended target was armoured plate. The method assumed intimate surface contact. Contact area drove localized rupture probability. The concept avoided precision aiming systems. Work moved through intelligence research channels. Trials used surrogate targets and metal bins. Early prototypes were hard to throw accurately. Adhesion testing dominated iterative cycles. Adhesive strength was judged by peel failure. Adhesive transfer contamination caused rework. Glove material interactions required documentation. Wet steel surfaces produced inconsistent sticking. Painted surfaces complicated adhesive bonding. Mud layers reduced contact reliability. Dust and oil reduced adhesive performance. Laboratory selection favored strong tack products. A stockinet layer carried adhesive load. Adhesive derived from birdlime was adopted. The charge body was a glass flask. Some references describe glass and bakelite. The body sat inside a woolen sock. The sock retained adhesive impregnation. The glass neck used external screw threads. A short handle provided standoff and grip. Handle material is often described as bakelite. The adhesive sphere required protective containment. 2 thin metal hemispheres enclosed the sphere. The hemispheres were spring-loaded for opening. A hinge at the bottom controlled alignment. A lever mechanism restrained the hemispheres. A pin retained the lever in transit. Factory instructions treated adhesive as hazardous. The munition was formally number 74. Designation included ST in documents. The device classed as an anti-tank grenade. Overall length is cited as 9.5 inches. Diameter is cited near 4.5 inches. Metric dimensions are listed as 228.6 millimeters. Metric diameter is listed as 101.6 millimeters. Service weight is listed as 2 1/4 pounds. A separate source lists 2 pounds 4 ounces. Explosive filling is described as nitroglycerin. One collection entry cites Nobel's 823 filling. The cited filling mass is 560 grams. Filling mass is also listed as 1 1/4 pounds. Nitroglycerin handling demanded strict segregation. Filling facilities required blast-proof cell layouts. Glass vessel inspection preceded filling operations. Neck depth gauging was a quality check. Thread conformity reduced cap leakage incidents. Flask annealing reduced brittle fracture rates. Rejected flasks were logged by batch number. Batch numbers supported explosive traceability. Adhesive impregnation occurred before filling stages. Adhesive workspaces needed anti-contamination rules. Stockinet cutting created lint contamination risks. Lint control plans were written for shops. Birdlime supply chains required non-standard sourcing. Resin and binder procurement faced wartime scarcity. Adhesive consistency varied by temperature bands. Cold storage stiffened tacky layers. Warm storage increased unwanted adhesion events. Transport packaging had to isolate tack surfaces. The metal hemispheres served as isolation barriers. Her hemispheres were finished in buff colouring. Some markings used a red ring. Paint schemes were standardized for identification. Paint thickness was limited to avoid hinge jams. Hinge pin fit was controlled by gauges. Spring force was specified for opening speed. Spring fatigue required cycle testing. Opening failures were recorded as critical defects. Lever geometry controlled release timing. Retention pin metallurgy affected shear resistance. Pins were sampled for hardness testing. Bakelite handle molding required controlled curing. Curing defects produced hairline cracks. Cracked handles failed in drop tests. Handle threads had to accept flask neck. Assembly torque was controlled by jigs. Over-torque risked glass neck fracture. Under-torque risked loosening during throw. Washers and seals reduced seepage risk. Seepage risk included nitroglycerin migration. Migration created sweating hazards in storage. Stores officers demanded temperature monitoring. Depots tracked maximum daily temperatures. Regulations limited proximity to heating pipes. Explosive filling required special packing notes. Units received handling leaflets with warnings. Training instructions emphasized short exposure time. The fuse system used a time delay. Published delay is commonly 5 seconds. 5 seconds drove immediate throw requirements. Delay was intended to limit enemy response. Delay also minimized operator proximity duration. Arming sequence required pin removal. Arming sequence required lever release. Lever release permitted hemispheres to open. Opening exposed the adhesive surface. Exposure created immediate sticking hazards. Exposure limited time for controlled aiming. Doctrine required closing distance to armour. Range was constrained by throwing capability. Range was constrained by operator cover. The design assumed contact before detonation. A missed throw produced uncontrolled detonation risk. A short throw produced high self-harm probability. A rebound off armour increased unpredictability. Sloped armour increased rebound probability. Curved turrets increased deflection likelihood. Wet armour reduced adhesive grip strength. Dusty armour reduced adhesive grip strength. Netting or stowage obstructed direct contact. External fittings provided unintended attachment points. Attachment to skirts changed blast coupling. Attachment to tracks reduced lethality. Placement against road wheels was inconsistent. Placement against engine decks varied widely. The fire risk increased near fuel vents. Some tactics targeted rear hull plates. Some tactics targeted thinner side armour. Operational guidance emphasized vulnerable angles. Guidance forbade frontal assault practices. Guidance still required extremely close approach. Home defense planning accepted high casualty assumptions. The weapon was issued to home guard units. Regular units also received limited allocations. Commandos evaluated it for raids. Evaluation criteria included portability and surprise use. Jeffress's unit later became MD1. MD1 produced multiple unconventional munitions. Sticky bomb design is linked to MD1. Demonstration reportedly influenced mass production. The Ministry of Supply was tasked for output. A target of 1 million is recorded. 1 million required distributed subcontracts. Subcontracts split glasswork and filling tasks. Glasswork supplied empty flasks and crates. Crates required shock padding and separators. Rail shipment damage rates were monitored. Breakage reports triggered packaging revisions. Filling factories received flasks under escort. Escort status varied by region and threat. Filling lines used measured mass dispensing. Dispensing accuracy prevented overfill pressure. Overfill risked neck stress and leakage. Underfill reduced explosive effect reliability. Quality sampling included weighing finished charges. Scale calibration logs were maintained daily. Nitroglycerin storage required bunded compartments. Bunds contained leaks and sweat residues. Ventilation reduced vapor concentration accumulation. Flooring materials were selected for non-sparking. The footwear controls limited static discharge concerns. Operators wore cotton clothing in many plants. Metal tools were minimized near filling benches. Non-metallic scoops reduced impact sensitivity issues. Glass flask insertion demanded careful alignment. Misalignment caused neck chip incidents. Chipped necks were rejected immediately. Rejected units were drained under supervision. Drain procedures were slow and staff-intensive. Drain waste required disposal authorizations. Disposal used controlled burning or detonation. Disposal sites were registered and guarded. After filling, sealing steps were performed. Seal integrity was confirmed by visual checks. Some tests used gentle inversion inspections. Inversion risked adhesive contamination of seals, therefore timing of adhesive application mattered. Production routing reduced cross-contamination points. Adhesive coating often preceded final assembly. Adhesive coating areas required solvent controls. Solvent procurement faced competing industrial demands. Adhesive curing times varied by humidity. Humidity control was limited in many factories. Variability increased rejection and rework volumes. Rework consumed springs, pins, and labour. Springs were sometimes in critical shortage. Spring suppliers prioritized aircraft components elsewhere. Procurement officers negotiated substitution alloys. Substitution alloys changed spring constants. Changed constants required retesting and approval. Approval cycles slowed deliveries to depots. Depots demanded predictable packing dimensions. Packing dimensions supported standardized carry boxes. A carry box held 5 grenades. To boxed inserts used circular cutouts for bodies. Clips secured the tubular handle section. Box halves opened through 180 degrees. Box design prevented adhesive contact in transit. Box design reduced accidental arming likelihood. Box latches were specified for glove operation. Field users still reported handling difficulty. Sticky surfaces could catch on webbing straps. Sticky surfaces could catch on overcoats. Accidental adhesion made retrieval unsafe. Training stressed avoiding contact with clothing. Training also stressed avoiding contact with skin. Adhesive removal procedures were inadequate. Solvents were seldom available under field conditions. Water and mud did not reliably neutralize tack, therefore protective hemispheres were critical. Hemispheres could be dented in packs. Dented shells impeded opening during arming, and opening delays reduced effective throw time. Opening delays increased operator exposure duration. Some manuals required pre-checking hinge motion. Pre-checking required handling and inspection time. Inspection increased risk of pin loss. Lost pins forced rejection or unsafe carriage. Unit armourers controlled pin replacement stocks. Replacement stocks were sometimes insufficient. The lever spring interface wore with use. Wear changed the release force profile. Users sometimes squeezed too hard, crushing grip. Grip instability compromised throwing accuracy. Throwing accuracy was already limited by weight. The mass distribution was front-heavy. Front-heavy distribution altered ballistic arc. The handle added leverage but not stability. Wind could redirect a short throw easily. Night use further degraded placement probability. The smoke reduced target surface visibility. Users were instructed to aim for flat plates. Flat plates were not always accessible. Tank stowage bins obstructed smooth steel. Side skirts blocked adhesion to main armour. Tracks were moving targets during engagement. Engine decks were angled and hot. Heat could soften adhesive and reduce grip. Heat could also accelerate chemical changes. Reports mentioned adhesion failures in rain. Rain formed a boundary layer on steel. Boundary layers reduced immediate tack. Some operators attempted wiping armour quickly. Wiping required extra exposure and time. Doctrine did not formally endorse wiping. Doctrine instead assumed sudden close ambush. Ambush required cover, obstacles, or buildings. Urban environments offered approach concealment. Open fields offered minimal approach concealment. Therefore, an operational utility was situational. Procurement still pursued quantities for deterrence. Deterrence value was part of policy calculus. Home defense planners accepted low-kill probabilities. They prioritized any chance of immobilization. Immobilization could block roads and bridges. Roadblocks could delay armor field thrusts. Delay bought time for artillery redeployment. That bureaucratic logic supported continued issue. Safety committees raised concerns about nitroglycerin. Nitroglycerin sensitivity required careful shock limits. Glass bodies increased shatter hazard. Shatter could expose explosive to impact. Shatter could spread explosive onto hands. Spilled explosive demanded immediate decontamination. Decontamination resources were scarce in units. Medical officers noted burn and blast risks. Accident reporting forms captured training incidents. Incidents included premature arming and drops. Drops could crack glass without visible damage. Hidden cracks could propagate under throw stress. That created unpredictable function failures. Quality inspectors used visual inspection lights. They looked for inclusions and bubbles. Bubbles weakened structural integrity under load. Anneal marks indicated temperature cycle failures. Failure rates varied by supplier glass recipes. Supplier audits attempted to standardize output. Standardization competed with urgency for numbers. Urgency often overrode best practice inspections. Some depots accepted higher defect tolerances. Those tolerances increased training mishaps later. Training mishaps reduced soldier confidence. Confidence effects were noted in liaison reports. Liaison reports influenced later procurement reductions. Procurement reductions reallocated funds to other systems. As PIAT availability improved, reliance decreased. Nonetheless, stocks remained in storehouses. Storehouses required periodic inspections for leakage. Leakage signs included oily staining on packaging. Oily staining required disposal and quarantine. Quarantine rooms were limited at small depots, therefore some units kept questionable items longer. Extended storage increased chemical degradation chance. Degradation could change detonation characteristics. Such risks were hard to quantify. Explosive chemists provided conservative shelf life limits. Conservative limits increased replenishment demands. Replenishment demanded more filling capacity. Filling capacity competed with other munitions. Ministry scheduling boards assigned machine time. Machine time allocations changed monthly. Monthly changes caused stop-start production inefficiencies. Stop-start lines increased unit cost per grenade. Unit cost mattered in wartime accounting. Accounting included labour hours and scrap percentages. Scrap percentages were elevated in early batches. Early scrap came from glass breakage. Early scrap also came from adhesive failures. Adhesive failures included uneven coating thickness. Thickness variation created inconsistent sticking strength. Coating tools included rollers and dipping vats. Dipping vats required viscosity monitoring. Viscosity changed with the solvent evaporation. Evaporation increased in heated workshops. Heated workshops were used during winter. Thus, winter output had different failure modes. Cold weather also stiffened Bakelite handles. Stiff handles could fracture during impacts. Fracture rates were tracked by acceptance tests. Acceptance tests included short drop sequences. Drop sequences used padded plates for safety. Even padded tests caused occasional shatters. Shatters required full area evacuation. Evacuation slowed throughput markedly. Throughput delays upset shipment schedules. Shipment schedules were set by regional commands. Regional commands submitted urgent demand signals. Signals often lacked realistic consumption estimates. Inexperienced home units over-requested stores. Over-requests clogged distribution channels. Distribution channels used rail and road convoys. Convoys needed hazard placards and escorts. Escorts drew manpower from other duties. Manpower shortages delayed deliveries again. Procurement officers recorded these circular delays. Minutes show disputes on priority coding. Priority coding determined allocation of lorries. Lorries were in short supply after evacuations, thus sticky bomb deliveries were irregular. Irregular deliveries complicated training planning. Training planning used weekly syllabus cycles. Syllabus cycles needed consistent ammunition allotment. Dummy grenades were issued for drill. Dummy grenades approximated weight and size. Dummy grenades lacked adhesive hazards. Therefore, drills understated real handling risks. Live handling required special supervised sessions. Supervised sessions used sandpits and nets. Netting prevented grenades reaching observers. Observers recorded adhesion success rates. Rates varied by target surface preparation. Targets were cleaned steel plates on frames. The clean plates overstated battlefield conditions. Some trials used painted plates for realism. Painted plates produced lower adhesion reliability. Rust layers produced mixed results. Rust could increase mechanical keying. Rust could also flake under impact. Flake detachment caused grenade drop-off. Drop-off could occur before detonation. Drop-off created ground detonation near operator. Operators were told to drop and cover. Cover distance was limited by delay time. 5 seconds limited movement options. Short delay increased pressure for immediate throw. Immediate throw increased likelihood of missed throw. Missed throw could strike walls and rebound. Rebound returned grenade toward thrower. These risks were discussed in training notes. Consequently, some commanders discouraged issue. Discouragement conflicted with central policy. The central policy prioritized any anti-tank capability. Policy memos referenced invasion threat assessments. Threat assessments shifted after air battle phases. Shifting assessments influenced continued production. Some production ran even as threat receded. Contract termination was administratively difficult. Termination involved compensation and retooling costs, therefore contracts often ran to completion. Completed stocks exceeded some unit needs. Excess stocks went into long-term storage. Long-term storage required periodic ventilation checks. Ventilation reduced fumes and moisture buildup. Moisture could alter adhesive state. Dried adhesive could lose tackiness. Over-soft adhesive could self-adhere inside shells. Self-adhere impeded shell opening. Shell opening failure meant non-functioning weapon. A non-functioning weapon created false confidence risk. Inspections attempted to prevent such cases. Inspections were labour-intensive for depots. Depot manpower was already under strain. Hence, inspection frequency was reduced sometimes. Reduced inspection increased variability in issued items. Field reports returned to ordnance offices. Reports were collated in weekly summaries. Summaries noted high operator hazard perception. Hazard perception reduced willingness for close assault. Willingness was essential for intended tactic. Therefore, tactical value declined further. Nonetheless, instructions remained on paper. Paper instructions required clear arming steps. Arming steps were printed on leaflets. Leaflets were sometimes lost in transit. Loss left recruits dependent on verbal briefing. Verbal briefing varied by instructor competence, and competence varied widely in home units. That variance increased accident rates. Accidents triggered local bans in some companies. Local bans triggered complaints from higher staff. Higher staff insisted on adherence to issue tables. Issue tables were derived from central allocations. Allocation formulas used nominal unit strength. Nominal strength differed from actual attendance. Thus, per capita availability was inconsistent. Inconsistent availability produced hoarding behavior. Hoarding reduced training exposure again. This feedback loop undermined proficiency. Engineers attempted improvements in later marks. Mark changes aimed at better safety handling. Mark changes aimed at better sealing. Mark changes did not remove close-range requirement. Close-range requirement remained intrinsic to concept. Alternative systems eventually displaced it. Displacement reduced priority for further refinement. Refinement halted while stocks remained serviceable. Serviceable standards were minimal under wartime pressure. Units sometimes retained them for niche tasks. Niche tasks included disabling abandoned vehicles. Niche tasks included demolition improvisations. Such tasks still carried extreme hazard. Hazard was accepted under certain conditions. Even then, ordnance staff advised caution. Caution language appeared in maintenance notes. Notes emphasized intact casing and secure pinning. They also warned against rough transport. Rough transport could crack glass unseen. Unseen cracks were the principal reliability problem. Reliability problems were reported as uncertain action. Uncertain action was unacceptable for many commanders. And commanders requested more predictable anti-tank weapons. Requests supported production of spigot systems. Spigot systems offered standoff and sighting. Standoff reduced operator proximity to detonation. Standoff also reduced direct small arms exposure. Such comparisons further marginalized the sticky bomb. The sticky bomb remained an artifact of urgency. Its design choices reflected procurement desperation. Its hazards reflected chemical and mechanical constraints. Its output reflected bureaucratic inertia and urgency. Its field reception reflected operator risk calculus. Its service life reflected changing threat environments. Its logistics reflected fragile materials and sticky coatings. Its testing reflected artificial target surfaces. Its manufacturing reflected distributed wartime subcontracting. And its safety record reflected volatile explosive filling. Its dimensions and weight constrained practical throwing. Its 5-second delay constrained safe withdrawal. Its protective shell was essential for carriage. Its adoption followed high-level demonstration decisions. Administrative decisions substituted for combat performance evidence. The weapon's continued issue was a policy residue. Policy residue persisted until better systems matured. Record-keeping preserved it as an expedient solution.